Welcome everyone. Thank you for joining us for today's webinar on blockchain need and implementation. I am Satyakshi from Spring People. We are India's largest enterprise training provider. Rajan, founder and CEO of Stacey, a do-it-yourself proprietary blockchain platform, has over 18 plus years of experience with deep knowledge in project management, team management, strategic planning and forecasting, budget allocation, etc. across MNCs like UNIS, SDM, HCL. He is a passionate entrepreneur and apart from Stacey, has also founded KennyCart, an IoT marketplace for products and solutions, and Blockchain Innovation Lab. He is highly proficient in using Windows Server, Linux, IoT, large data center incident, blockchain, and related technologies. He is certified in various technologies like Microsoft Certified Systems Administrator, Red Hat Certified Linux Engineer, IBM Certified Storage Specialist, to name a few. In this webinar, Rajan will introduce you to blockchain and emphasize its importance in the present era and help distinguish between databases and blockchain. He will also describe the blockchain ecosystem and will throw light on technical aspects. If you have any questions during the session, please type it in the chat box and they will be addressed by Rajan after the presentation is over. Without further ado, let's start today's session. Over to you, Rajan.
Thank you, Satyakshi. Thank you so much and welcome all. So we are starting on a good note after the lunch. All right. Yeah, we can move on. So you all can see my screen, Satyakshi, right?
Yes, we can see.
All right. Wonderful. So today we would be just as part of the agenda, we'll be talking a bit on blockchain and the evolution of blockchain and what is the value proposition blockchain brings in and how seamlessly we can create blockchain solutions. So I just also will be demonstrating live on the platform on how we really can use multiple blockchain technologies seamlessly without much of the effort, right? With higher efficiencies and go to market will be much more faster. Just we'll be moving on with that, right? As you know, Stacey, it's a do-it-yourself blockchain platform which helps enterprises to deploy blockchain seamlessly with ease. So I'll just would be talking more on this as we move on, right? So there are multiple blockchains available which we'll be talking about on what are the value propositions each of is and what are the consensus protocol each one of it goes with and what are the advantages and disadvantages of each of this, right? So as you know, we started this journey in 2017 when blockchain was quite nascent and there was a lot of noise around blockchain, right? So that have subsided in the last 3 years or so, and you can see realistic people who are building real tech are into the game now. I think blockchain is now widely being used. It is in the next 2 years, 12 to 24 months. Most of the POCs are moving into the production, and everyone got wonderful opportunity for the people who understands the blockchain tech in Hyperledger or Ethereum or Quorum. These are the and Corda. These are the 4 blockchains which is doing well and have around 80% of the market share today, right? So what is needed to learn blockchain? So you don't have to have a prior knowledge of blockchain. So it is good to have some kind of network skills for you to understand blockchain. From the program standpoint, if a person understands JavaScripts well, they can understand the Solidity and learn in a very shortest possible time, right? And for Hyperledger, we use Golang chain codes is something which need to be understandable, right? So this we don't cover too much of those things, but on a high level we will be covering on some of the code part which we would be taking you through to have a better understanding on how seamlessly you can learn blockchain as part of upskilling yourself, right? So we start with a simplified overview on how it works, then we get much more deep into it on each of these sections. So I will be taking another 1 hour 15 minutes time, and 10 to 15 minutes we will allocate for the Q&A before we call up, right? So what we need to know, so one is the distributed systems, peer-to-peer networks. We will be discussing about hashing functions and how the hash works, and what is a public and private key cryptography and how it works, and cryptographic signatures, what are the significance of those. So blockchain technology is both technical and intricate. So it's a bit complex for people to understand on where to use, why to use, when to use, right, and how to integrate. So we are not going to jump directly into the code part. I'll just walk through on the fundamentals of blockchain before we discuss on those things. So our aim is to give you some base understanding so that you can decide on which blockchain will be good for you to go on to learn, right? So in simple terms, blockchain is nothing but a distributed database. So all these days we have been seeing centralized systems in place. So we have been working on those. Client server architecture has been there for quite long, but there are certain challenges to it, right? So because your data resides with one person who is the administrator, who will have complete access of the data, right? But however, your blockchain is quite distributed. So when it is distributed, so your data is scattered across as in multiple nodes. So each of the organization, the discrete organization which will be part of the blockchain, will have potential benefits, because without having to compromise on the data, you still can share your data across to all your partners. I'll just also walk through on some of the use cases from the pharma standpoint, because most of you are from the pharma background, working with the pharma company. So I'll be walking through on some of the use cases on that front to connect things much more better, right? Uh, so it holds the records of digital data, and in the way that makes them tamper resistant. So blockchain is tamper resistant. Even if you delete it, people get caught on. It is quite tamper proof. So because for each of the actions which you perform on your database or on the blockchain, there will be a timestamp which comes up, and we know about who has changed it, and you can also track things backwards. Traceability is one of the important factors of the blockchain. So any kind of transactions which happens on the blockchain, it's backward, you can track it. A complete historical view can be seen once you put the cryptographic hash, and from where to where it is going. So all these things will be in picture. So you can optimize the cost mostly in terms of in the traceability solutions, and in several use cases where security is a challenge, like a medical records use case, which we'll be discussing about further. We will be talking on what are these 4 or 5 use cases which will be beneficial in the healthcare industry. So breaking trust factor concerns is a major concern today, right? So people don't know, right? Because multiple partners work together, and there is a trust deficit between all these partners. So how do you trust the other partners without having to compromise the data integrity? So blockchain comes into picture for that, and it brings you a better security, reduced risk, and reduced fraud, because you are not compromising on your data, but whatever is needed for the other parties to look into, those things will be shared across all the parties. So we bring in a lot of transparency and efficiency, because you just can set up things quite fast, and you can share the data between all the partners so that they can take informed decision. So your overall operational and capital cost is going to come down once you have informed decisions between all these parties. So security, because data is decentralized, obviously it depends on the number of nodes which you want to spin off. You can spin off that number of nodes, and you can also create a governance structure on how exactly your blockchain need to behave, right, between all these partners across the consortium. So multiple companies coming together are called as consortium. It is quite auditable. Auditable in the sense, if you see in many use cases, auditability is one of the functions, right? Be it in banking, financial, insurance, pharma, it's once again in a clinical trial process, right? Everything is need to be auditable across. So you will have a real-time audit which can be done by involving the regulators as well as all the companies who are part as part of the partners, right? And you can remove all these intermediaries. So today, if you see, all the intermediaries is adding a lot of cost. So for banks, you have all third-party providers, you have the POC devices, you have a lot of things which are there in between, which is eating away a lot of your money, right? Because of the service which they offer. And the brokers in terms of in the stock exchange, you will have brokers in between. So blockchain helps you to have some kind of consensus mechanism, so that blockchain takes care of the consensus part and you can take care of your core domain, and your overall cost is going to substantially reduce depending on how you want to treat your blockchain, how the data is shared between multiple partners. That ROI need to be built up based on the, because blockchain does not work for one organization. So calculating the ROIs is a collaborative approach between all the partners. So it all starts with the transactions, right? One is no middleman required. So fraud detection is quite easy for you to do it. So you can have sufficient trust between multiple partners, and it's quite anonymous and private transactions also happens. So there are multiple kinds of blockchain. You have a public blockchain, you have a private permission blockchain. You depending on the use case which you want to go with, you can go with those blockchains which are needed and how your data is shared across all the partners. So it's distributed, as we all know. So if you talk about the electronic middleman, today we don't need, when we go blockchain ready, right? I'll just talk about, if you see the picture here, so you have a merchant bank, you have a processor, you have a Visa network here, card issuing company, right? So all these partners will be part of the consortium to have a seamless user experience, right? And so the data will be quite real. You don't have the kind of frauds which happens in the banks today. Most of the use case like letter of credits, where you see a scam like Nirav Modi scam, which happened, a $2 billion scam, because things were working within silos. And once you have blockchain and connect all the banks together, at least from the letter of credit standpoint, you can avoid those frauds, right? So what are the costs which is adding into the current system? So provision of infrastructure is one, is terminals, network connections and all. You have management of commercial relationship between parties, that is adding a lot of cost. So there is a lot of abstraction of complexities can be removed using blockchain, and fraud detection can be real time. You can look into how the data is getting shared and behaved, and some of the contracts which are needed can be directly put on the blockchain so that it will be self-executed. So you can comply with your regulatory compliance. So I'm just talking with respect to the financial industry, but in a healthcare industry, you have a lot of regulators, right? So you can bring regulators as part of the consortium and provide seamless experience, so that you will be complying with what is needed, right? So transactions volumes are going. If you see here, the number of transactions after the COVID happened, it's drastically increased. One couple of billion transactions is happening on our UPI network today, right? So that is growing substantially. People are now adopting to online purchase because of the safety reasons. So this needs a lot of trust factors which need to be worked between all the partners. So blockchain is going to come handy with this. And during the time of pandemic, it is working out really well. And most of the countries today, be it China, be it Russia, US, have passed bills to bring blockchain to technology on the core, at least from the traceability and supply chain standpoint, right? So the easier it is to conduct the transaction, the more people will transact, right? So ideally, when things are much more easy, it is easy for us to have more people adopt to that technology. So that's what we are doing as a company. And I think most of the other verticals also, if it is easy, people will adopt. So why do we today go with the online banking just at the fingertips we have on our mobiles? Because it makes our life more easy. So in the same way, every other vertical is going in that direction and adopting to the digital transformation, right? So we all know cash is a king, right? But useful locally and in small amounts. So electronic fees requires credit and debit card that adds a substantial value to it. So today, Microsoft and Bank of America is trying out on the international payments on blockchain network, which is going to substantially reduce the time it takes for you to transfer the money between different countries. So ideally, in a SWIFT system, it takes around 3-4 days. So that is going to come down to 5 minutes. So which we can see in the next few more months, 12 to 24 months, we could see that reality. It's more the seamless payment integrations happens on the blockchain, right? So blockchain powered payment networks. One is what is being solved is the speed, trustless trust, no special equipment is needed, fraud detection happens, and minimal cost for you to do the transactions. So some of the things which has been ignored is the KYC process, AML, anti-money laundering kind of a thing, onboarding process. So all these the things which has been ignored, and now it's been moving onto the blockchain with a better value proposition for the customer. So that is on a high level about some of the aspects which I thought we need to cover up, right? So let us come back to the subject on what is a blockchain, how it got evolved, right? So it all starts here, right? So if you see here, the way they were transacting early in the olden days, say around 100, 200 years back, right? So you had something called a block where there is a village where there is a block. So this village has put a value for this particular, particular block which is having. So they are going to transact all the goods through this particular thing, right? So once you create a value out of it, the people will chase for it and they try to go and mine it. They go and mine to see that how I really can catch hold of these things. So during the process, they they go and search for these blocks, and they come and put out in the form of a ledger. So this is a ledger which is getting formed, and they're going to mine all this, right? Because it has some value, be it it is a value which has been created by all the human beings, right? Be it gold or diamond. Ideally, it is a stone if it is a diamond, but if you perceive that to be having a value, and definitely it creates a better value proposition. And so at the end, it's all humans which creates value for an entity. So in the same way, the cryptos which is being running on top of the below the blockchain also has been created some value by the people, but because of regulatory constraints in different regions, most of the companies are not touching, at least from the India standpoint. But globally, it is getting accepted, be it in Japan, Australia, US region, all thriving in that area. So we could see a lot of innovations in that area. So what I mean to say is, as long as you start create and see some value in it, that keeps growing. So be it a stock in a stock market, it's ideally you can see a lot of volatility happens in the stock market. So you have some announcement coming in, and suddenly it keeps going high because the perceived nature of the person who believes that that particular asserts is going to create value for them, right? The same way, even these things also works out, right? Ideally, if you see, the stone themselves had no monetary value, but the value has been created by the people. And eventually, if you see, spending your stones didn't require physically moving. So I just say that this is my asset, so I'm going to transfer to you. So this is like a land where we create a value for the land, and we are not moving that land from one person, but we are just selling out and uh, changing something on the ledger. So that means you go to a registration department and say that I'm going to purchase this land. So now it should be on my name. So the maintenance of ledger in a proper way and sharing of this ledger between multiple partners is what blockchain does. So the ledger will be shown across to all the people who until now don't have trust in transaction between multiple people. Tomorrow, even your competitors might come and join your blockchain network, but you don't need to really compromise on your data. At the same time, in the benefits of the customer, whatever data need to be showed, those things will be showed across the chain. So, and they developed a form of distributed ledger, which I showed earlier in the previous images, right? So blockchain is the implementation of the overall ledger. Ledger records transaction and which passes on the value, and transactions are time-based. Once the transaction is recorded, you cannot alter. So that's the beauty of the blockchain is once you commit any transaction, you cannot go back and change it. So you will be caught. So ideally in a normal client server kind of an environment, you can go and if you're an administrator, you go and delete the record. But that does not happen on a blockchain network because your cryptographic hash will be tagged to each of your transactions or each of your update what you do on the blockchain network. So you need to be able to detect if your ledger has been altered or not. The blockchain is a protocol for immutable historical records of transaction. That is one thing to make a note of. So I just would be quickly moving on now. We have a lot of other slides as well. So blockchains are also called a distributed. So if you see here how the network evolution happened from a centralized, we see a decade back, it's a centralized system we have been using for that. Then we got decentralized. Decentralized something where you got something called Napster. You got torrent where multiple downloads were happening from different sources, right? And now we are seeing a distributed where each of the parties node will be talking to each other node. If you see here, it's all completely every other party node will be having data of the same data which other people have. So the beauty of this is even if as long as two nodes are there live on the network, you will never lose the data. That is one aspect in terms of security. And second is you will have all the information, all the people having the same data available across. So if one person is tampering, other person will be knowing about. So many equal nodes we could see, and each node has multiple connections to other node, and it is very resilient to failures or attacks. And hacking does not happen much on the blockchain network. Probably on the application layer it happens because your application sits on top of it. It happens, but getting into the blockchain network, changing the blocks, changing the hash, it does not happen. Till we have something where your quantum computing comes up and do something on that, but we are very far away for understanding those, right? So who invented this, right? 2009 first block got created. So block is nothing but your blocks keeps on creating in the blockchain. Each of the consensus protocols which you have has a different mechanism on how much time it takes for you to go and create a block. Say that in an Ethereum network, every 5 seconds you will have a new blocks created. So whether you have transactions or not, your blocks keeps creating, and when your transaction is committed, it goes and put on one particular block, and you will have a block number for that particular block, right? And this guy is Satoshi Nakamoto. We don't know who that is, but he has developed a blockchain, and he till date nobody knows about who is that. It's only a pseudonym which has been given. So early days, it was just him, her, or it. Then there were early adopters who were interested in some kind of bitcoins at that point of time, right? And want to understand the technology behind it. But now what we are talking is not crypto's part. We are not covering. We are covering more with respect to a blockchain technology part. How this particular technology can be used in different verticals. Different areas where there is lack of trust and transparency, be it in supply chain, retail, logistics. You have pharma in pharma medical records. You have medical device traceability. You have clinical trials, and one other use case is drug supply chain. Right? These are the 4 use cases which is widely used for the medical fraternity, right? Healthcare fraternity, I believe, right? So I think blockchain has come a long way. If you see here from 2009, it's almost a decade is there, but blockchain as a technology has evolved a lot. So we see today a lot of these four top blockchains which I talked about: Hyperledger, Ethereum, Quorum, and Corda. So these are the four blockchains which is adding real value in terms of technology. So why conspiracy theories are fun? It's more relevant. So operational design was published open. It's open source. Okay, you can go and Google it, saying Satoshi Nakamoto white paper. You will get a white paper. You can just go through, read it to understand the complete history behind it. So the protocol is completely open source. It is accessible, and you can use that. So code is open source and has mostly been rewritten many times by many open source community. So is it money, digital cash, or digital gold, right? So what are the characteristics we have for the blockchain? One is it is durable because it is safe for long-term storage. I'm talking about crypto part. It is portable and it's easy to move around. You can transfer between multiple partners. It is divisible. It is uniformity. It has a limited supply. So when you have a limited supply, so you know about where things are going. Today, the currencies which we have, we don't know how much money we have in our country. And at least in the US standpoint, the federal government during the COVID crisis, they have already printed around $2 trillion. So nothing is accountable as such. So when you go with the digital currency kind of a thing, it is easily trackable, and it will have a worldwide trust and transparency on where exactly the money is moving. So money laundering does not happen. Your black monies will not be there. Right? Much of the things can be sorted out as the technology in the next 24 to 36 months. We could see some very good decisions coming in, even from different governments across the world. So is it a legal tender? As of now, no, because of the various challenges which the regulatory has. They don't have the required bandwidth to see that how it's been managed. So it's just kept aside as of now, right? So a lot of things aren't legal tender. So be it gold or diamond or Rolex watch, all these are not a legal tender, but it has a value, right? The value has been created based on the demand which we have. So in the same way, blockchain also has a demand uh, based on the supply demand match. It keeps the technology is getting adopted. So what are the ecosystem developments which is happening, right? So blockchain today have been likened to the internets of 1990s. So if you see here, when the .com has come, nobody understands about how the internet works those days, right? So everybody was into the nascent stage, and companies like Amazon and all thrived out of it, understood the business models, and they created some wonderful business models. And you have similar investment levels. That means in 90s, when you have a website, you were able to raise millions of dollars, because that time it was like crazy investments was happening before the .com boom burst, right, way back in 2000, right? We could see similar kind of things happening in blockchain, because we have seen a hype cycle in 2017. A lot of companies have raised tons of money in the form of initial coin offering, putting in exchange. So all this have gone away because the business has not been proven, and people have pumped a lot of money. Now that noise have gone. Now we are seeing a real technology, and people who are building a real technology are the game changers, right? It's considered to be a parallels to the internet. So I think the way the enthusiasm in terms of blockchain which we are seeing, it is much more similar to what we saw in 1990s. So but it took almost good amount of time for the companies to figure out how blockchain can add real value, and how they can optimize their capital expenses and operational expenses, how they can show better ROIs, right? So those things are happening as we talk. A lot of things are happening in that area, right? So this is the curve where you could see innovators, early adopters, early majority, late majority. So now we are in the upward curve here, where you could see a lot of late majority happening here. This stage we came out of it, right? And we are here in this stage, right? Some of the investments which happened, wonderful investments, a lot of big companies have created a wonderful value propositions across. You have some of the well-known people in the world have invested and believed in the blockchain technology. And I think in the next 24 to 36 months, we could see this in better scale, right? And now that we have figured out on what use cases really works out, from now the innovation will be much more faster, right? So there were a lot of other coins which came in with different value propositions. There is a company called Namecoin which provides a distributed DNS. Instead of a normal DNS, they proposed a distributed DNS. So there is something called Colored Coin with Counterparty and Omni can tag and track digital assets can be tracked through that. So there is a company called Filecoin and Storage. It's a distributed cloud storage where you can share your spare hard disk and a blockchain network will be formed with that. So those companies are early into the game. They're still working out, but it's a bit tough to crack when you already have a lot of cloud providers, which is much more faster. Blockchain is a bit slower in terms of throughput, so that those things are getting worked out with different technologies like sharding and other things which are happening in different blockchains, right? So evolution of network, if you see blockchain 2.0, now we have come a long way. So companies like IBM, which has partnered with the Linux Foundation and come out with the Hyperledger, different versions of Hyperledger, be it Fabric. You have something called Sawtooth, Indy, Iroha, different blockchains for different verticals, right? So some of the rules of the blockchain is, as I discussed earlier, data written into the blockchain is a historical record and is immutable. You cannot tamper with. So once it happens, nobody can change it. It will be remain there forever. So blockchain have to prove that they haven't been tampered with. Everyone running the blockchain has to agree the data stored in it, right? So this is how the transactions happens on the blockchain. It is grouped together into a block. So I think your blocks keeps on creating. I will show you live on how exactly your blocks keeps creating, right? I'll just rush through this. So ideally, it first 5 creates, then again it refers to the previous one, then again it goes like that. So blocks are numbered in the ascending order from 0 in the first order, and it goes to the higher level. The number is called, the number changing of it is called the height of the block. So arrows go from newer to the old block. From the old block, from the newer block, it goes to the old block. And once a block is stored, it's read only, you cannot tamper with. So this is how it goes on. So this is the hash of each of these, which will be stored in one of the blocks. So your blocks keeps on moving away. So when you have something, a transactions in your database where you are connected with the blockchain network. So when that happens, say that during the time of the transactions, you are on block number 3. At that point of time, your transactions will come and store on block number 3, right? And this is how the hash will be generated here, right? So you will have in the metadata, what are the things you will have? One is a version number, a link to the previous block you can find. You can find a timestamp, you can find a Merkle root, which is quite complex. I don't want to deal in this part. At least we don't have time for that. So mining difficulty is something on how difficult is for anyone in a public network. You will have miners sitting across the world who will have rewards, and they need to solve the complex mathematical problems and put those things on the block. So for that, they will be rewarded. In a private network, you don't have to really mine because your software itself mines. So that's the difference between a public blockchain and a private blockchain. So all transactions that were recorded in these blocks. So this is how it works out. These are the blocks. So these are the parameters which get stored. So there are multiple kind of consensus, which is called of proof of work. You have proof of stake. You have RAP protocol. You have Kafka protocol. You have IBFT protocol, Byzantine fault tolerance, and there's a lot of things which we can discuss. But in the best interest of the time, I am just showing on a higher level to see that how it works out. Right? It's tamper evident. Blocks are identified by their IDs. Metadata in turn contains Merkle root, and it changes the metadata. And as I showed in the previous screen, you will have hashings which gets put on the blockchain. So blockchain solves specific problems only. It is not for all the use cases. Your database is good to do work if it comes to a normal use cases wherein you are not sharing data with any party, and if you don't have any trust and transparency challenges, you still can go with your normal database. You don't need a blockchain, right? Blockchain works out only when you have multiple partners, where data is shared across, where there is lack of trust deficit, right? And when you want to see the historical chain of events, when you have some kind more kind of automation in terms of smart contracts, where you don't want a lot of human intervention between all these parties. But for a normal things, your centralized computing, your database still works absolutely fine, right? So beauty of the blockchain is everyone has the same kind of copy of what you have, right? It's like a read-only distributed database which you can talk about. So everyone running the client is part of the network, and new blocks are broadcasted to the network. So everybody knows about what particular block is currently running on the blockchain. So what are the current challenges implementing the blockchain today, right? So building blockchain is quite complex, and because we don't have too many developers today on a blockchain, and getting a developer is always a challenge, right? A guy who is really solid, uh, be it in Hyperledger, who uses a different technology, the solidity you need to have a altogether different kind of skill set, right? And it's quite expensive to build, and it takes longer time for you to do it, because when you want to develop any kind of POCs, so you need, what are the people who you need? You need a front end back end developer, you need a cloud architect, you need a cloud developer, you need a security architect, you need one program manager. So 5, 6 to 7 resources for you to plan things well, do a due diligence, and integrate your things on the blockchain network, right? So those things can be eliminated by using a the platform like us, what we build, a Stezi platform, which will help to add tremendous value in creating quick POCs and moving on to the production, right? And with lot of other ecosystem tools, and maintenance is again a challenge. So all the maintenance tools are part of the platform offering, with higher security, with a virtual private cloud, which will be completely segregated when we talk about the enterprise, right? So some of the solutions is like, it's a DIY platform kind of a thing. It helps you to save a lot of time and cost. Completely automated things with Hyperledger, Ethereum, and Quorum, the top blockchains which I talked about, can be integrated directly on the cloud, or bring your own cloud, or on the premise. So with API integrations, which will be auto-populated, auto APIs will be created, auto codes, predefined contracts which are already there can be used, and you can directly integrate with your existing applications, right? Some of the things which I want to share is, it's quite fast and cost effective. You have a mix and match of different technologies available, and you can create, innovate, share solutions across all the partners. Coordination between multiple partners, right? Say that you have 5 different organizations. So it's difficult for you to coordinate with their technical team and bring them onto the network. So that is going to solve the problem. We have solved those problems as well to create it. It's quite easy to explore, build, we extend, and we transform. And some of the things I just want to move on. And there are some of the use cases which is much more specific to the, what do you say, our pharma industry, healthcare, right? There are some use cases which we can go through, right? So these are some of the use cases in different verticals where blockchain can be used, right? Be it in compliance and regulatory. In healthcare, we have personalized medicines, record sharing, compliance, agriculture authentication, pharma purity, and all. So before I move on to the next slide, I'll just will create a blockchain live to show you on how exactly it works out before we integrate the contracts, right? So the advantage of this is like you can go and build your code directly here. You can upload your code, you can write the code, you can compile and deploy directly, right? And you can also create blockchains of your choice. So I already have a blockchain here, a supply chain blockchain with around 3 different nodes. You can find when it got created, what is the network type and all. So ideally, if you want to go with, you need to develop all this. So things have changed a lot. Now automation has come into picture, right? So now it's all low code platforms are going to thrive. And you need to still understand the blockchain, but most of your monotonous task of what human is doing today, that is going to go away anyways, right? So this platform helps you to have a rapid prototyping and quick production deployment. Say that I'm going to create a blockchain. I'll just go and create a blockchain here. Say we are going to create a supply chain, drug supply chain blockchain, on how seamlessly we can go and create. So there are multiple protocols and algorithms which are part of it, and we know about what each of these things do, right? I'm going with Ethereum protocol, Ethereum blockchain. So I'm going to create a node. Node is nothing but your endpoint kind of a thing, right? You are separately create a VM with all the blockchains which are needed. So I'm going to check out. So what is happening here is whatever you have to do and write the code, so you don't have to do all such things. So you can just start creating solutions on top of the platform, so that your time to market will be much more less. And you still need to understand the bit of coding part, the Solidity and the Golang which I'm talking about, because we have to customize some of the contracts. But what we did separately is like completely eliminated and reduce the time it takes for you to build any use case, right? Flat in a week or so, right? Week, couple of weeks, you will all be ready and you can go and demonstrate across. So this ideally takes around 9 minutes time, 9 to 10 minutes time. So I'll just move on to the use case before this gets created. So you have multiple things happening on the back end, like initiating the blockchain creation. You have the master node getting set up. You will have a blockchain explorer getting set up. You have multiple other things which happens, right? So I will go back here and I'll just go and walk through the other aspect of it, right? So if you see here, some healthcare record, some of the challenges, what do you see in the healthcare record? So I think most of the healthcare record in the world are getting hacked, especially in the advanced countries, in US, in other parts of the world. Hospitals and healthcare providers have to pay very heavy penalty to the regulators because data is getting compromised there. That happens every other day. We could see that billions of dollars is getting lost because your medical records are the key for you to really, to maintain the confidentiality of the patients, right? Patient consent and security and privacy are the important things to run the healthcare business. So data mobility, integration, and interoperability, that is some of the challenges which we see. So we are also working out with some of the pharma companies for providing this healthcare records for the hospitals, I mean, right? So blockchain is secure by design. As you know that blockchain is secure. So information is quite tamper-proof, better coordination between various consortium partners. So you don't have to compromise on the security. At the same time, you can share your medical records to the diagnostics, to your doctors, to the hospitals, to any other person who is part of that particular network, right? So this is how it overall works out. You have all the healthcare providers here, which is connected to the blockchain network. You have hospital records, which is going to the hospital. You have diagnostic details, medical details, which is going here. You have prescription drug details here, which is going to the pharmacy. So pharmacy knows, surgeon knows, lab knows, cardiologist knows, physician knows, and you have your personal information getting stored, and your patient will be having a full permission of that his records. And that's how this particular use case works out. And there is again a counterfeit drug is one of the biggest challenge here, right? So we are working out with some companies on the drug supply chain part as well, on how these things works out, right? So one is counterfeit drugs that are genuine in appearance. Ideally, in India, we have 40% of the drugs mostly are counterfeit today here. So it's a wonderful use case to explore to see that how you can track your drugs moving from the APIs to the manufacturer to the to the warehouses to the distributors and to the retailers to the patients, right? To the people who are looking for that medicines. So the complete details of how the FDA approval happens to the time it goes to multiple parties from the API manufacturer to the shipping company to the warehouse to the repackaging unit, every other details will be tracked. So these again medical device traceability. We have few customers in the US region for medical traceability. So this is how it works out. It's a real-time monitoring of the large medical devices which are connected to the network, which has the MAC and the serial number, wherein you can track where your devices is and how it is moving across the chain. All right. So these again are clinical trials. Because you need to have multiple sites which are part of it, and so that will add tremendous value to see that how your overall development of the medicine drug is happening between different sites. So you have multiple CROs, multiple partners as part of it. You have a sponsor company, parent company who does all this. So these are the something which happens in this in the medical area, healthcare area. So we have several other use cases in various verticals in the government. We do for law enforcement, connecting forensic, fingerprint, police, and all these departments. A lot of other use cases we are working out on in banking, financial, insurance, and logistics area, right? So I think that's good to go with. So you can reach out if you need any kind of blockchain help or anything. You just can. I am connected on LinkedIn. You can connect, and this is the place where you can guys can contact for more anything which you want to develop on top of the platform, kind of a thing, right? We are there to help you out for that. So coming back, I think this is in brief. We'll just in the next 20-25 minutes, we'll just should be talking about the code part, and we'll also be talking about how the blockchain is working, right? So here, if you see now, your blockchain is ready, right? So under 10 minutes, all these steps happened. So whatever steps has to be there, it will be there. Now you already have this Explorer, which is self-installed with this. So if you see here, so this is the blockchain explorer. This blocks keeps on creating as we move on. You have a 38, 37. So in the next 5 seconds, every 5 seconds, you will have a new block which gets created. Right? I have one more block now. Right? Let's see one more, another 5 seconds, you will have one more block. So in each of these blocks, there will be transactions which comes up. So this is the real time which I'm showing you on how it works out. Right? So I'm just having it here. All right. So this, you can add multiple partners as part of it. You can invite the organization. You can invite the organization. Once you invite the organization, that partner will be part of the network. You can either invite through an email, or you can directly do it through an invite organization. And you can create a node directly from here. Multiple nodes can be created. Now your blockchain is set up. No need of writing a code directly or there here, right? JSON Genesis.json file is something, a configuration of the blockchain, right? A configuration file of the blockchain. You can download it, you can tweak it, and you can do whatever is possible. So a couple of other thing is, you can create a hyperledger as well. You can create quorum network as well. Everything you can deploy in the region of your choice. Be it if your company is in US, to protect your data, you can store it in US region, and India has some kind of data protection laws. You can do that as well, right? So coming back, you have several other tools, like you have a vulnerability check. Before you go and deploy any contract, you just can go and take up the code. So directly there is a code you can directly write within it, and you can request for the audit. You can scan for the vulnerabilities and deploy it. So all your vulnerabilities will be checked on the contract, and you will have a security report coming up. And all this, you don't have to really do all this nowadays. Testing has completely become automated, so you don't have any tool to really test the smart contract and chain code which we have come out with, right? And you have multiple things where anyone can request healthcare vertical. You have different kind of verticals you have to go and develop on top of it, right? And you can also create an application. Say that I'm going to create a drug supply chain. And what I'm just saying that I can quickly build an application. Company name. Some I can say company ID. I can more say some purchase order number. So now I'm going to deploy this onto the network. Right now it asks about where you want to deploy. So you are creating a real application where you don't want to really do any kind of development there. Just a quick putting a couple of fields which can be shared across all these partners. You just want to go with, and I'm going to deploy this. So your contract is successfully deployed now, right? Now I have built an application quickly, and I just can go with company name. Say I'm going to submit. Let me say that I'm going to submit this record onto the blockchain. So now it got submitted. Your record is submitted and it can be viewed across all the partners, right? So ideally, if you have to do all this, it's going to take tremendous amount of time, effort, planning to do it. Now you are going to do it all seamlessly, right? So I'm going to the app and I'm going to see that how it got stored. Now you have an email coming in saying that it's all done. I'm going to go with, I'm going to view my receipt. So this is the transaction hash, blockchain hash, which I talked about, which is happening. So my particular transaction is stored on block number 89, right? So let me go and check if block number 89 has our transaction or not. So your 89 has a transaction which is successful, right? I go and dig deep into it, and I say that this is a transaction hash for that particular transactions. So this particular transaction is successful, and all your partners can also see the same kind of information across, right? So you can do that wonderfully well. So now let me just go and invite other partner. So say this is a new organization called BCIL. I'm going to copy this and I'm going to go back here, and then I'm going to invite the organization. So I want to share my data with the other organization. So I'm going to host it in India. So my invitation has successfully gone there, and I'm going to go to the other organization. Now I'm going to accept the invitation. If you see here, now we earlier used to have 3 nodes. Now we have 4 nodes. That means you have 4 endpoints which got created. Your data is lying in 4 different places, so it will never be compromised or going. Even if one node is compromised, you have other nodes. So this is the node owned by you. This is the other member nodes, right? So all these are running into the active state, right? So this is how it works out, and this is the current status of initiating. This is going to take another couple of minutes for the integration to happen. So in the meantime, there are a couple of other things which we can walk through on in terms of multiple smart contract which we have. So you can design the contract, say that anything in a blockchain is an asset. Asset can be a drug, asset can be a document, asset can be your land, anything is an asset. It's about updation of an asset, deletion of an asset, transfer of an asset, tracking of the asset. These are the four things which happens in the blockchain network, right? Say that I'm going to create a supply chain network. I'm going to create an asset, and how seamlessly it happens. Let's see that we are going to go with something called say medicine one, right? Something medicine one, which is of string type. So I'm going to add these two. These are the two assets which I want to track, and I want to deploy this on the blockchain network. So your contract is successful now, and you have something called asset builder. Asset is been built, right? So you have whatever code you have to write. Now this is what it is auto-generated fully, which can be plugged into any application directly. So you have a bytecode and you have an API which comes up, and I'm going to create an asset. So this is what we have given. Say something. What is that? Regular used medicine. Something called crocin. Something called. So these are the two assets which I'm going to track. I'm going to create an asset. So your asset is successfully created, right? You already have it. Now I just have a hash which got generated for this, and let me just go and check the provenance. Provenance is nothing but how your date transfer is happening. So 1556, there is a hash which got created by this. So I want to transfer this asset. All this has an API where you can directly use it in your applications, directly explore those things. So it will be easy for you to go and create any use case on top of the platform, right? So let me just go here. So now this is running. And now let me just go and create one account. I want to transfer my, you have an information on how you can connect this to, and start using it. So I'm going to transfer that particular asset to this account. So when I transfer this, I'm putting this and transferring this. So your asset is successfully transferred, right? So now if you see here, a historical trail is getting formed. At 1556, you have created an asset. 1558, you have transferred. But in the front end, you can do some changes to have some kind of human readable format, which you can put across. So that we have given that option for the customers to integrate directly. So this is one way of doing it. So you have multiple ways of creating anything, whether it's a public blockchain or a private blockchain can be done. You can go with chain codes, multiple smart contracts, vulnerability tools, and you also have a IPFS network to store all your files securely share between all your partners. All right, and then I'll just show you the other one. Okay, so now you also have a code builder, right? How do we write the code here, right? You can go and say supply chain. I'm going to upload my code. Hey, Nagendra, would you like to walk through on this?
Yeah, yes, Raj.
Okay, right. All right.
Hope I am audible.
Code which we have. So if you have to write all these, right, you can have an option for you to write the code or upload it with a predefined code which is available. So, yeah. So I'm just scrolling, Nagendra. You can walk through.
Yeah, and here this is the generic Solidity smart contract which is written for this particular use case. What is that use case is supply chain. If you come to this particular use case, what type of things when a business expects is you have to transfer. First of all, you have to create an asset. Once the asset is created, you have to transfer that asset to the second party. That is, if the asset is created by owner, the second party which the asset needs to be transferred should also have an unique account. And the third thing is tracking of this asset. When the asset is created, when the asset is being transferred, these type of tracking will be maintained in this contract. And if you see here in this particular contract, coming to the line number 1, this is like as we have generic standards of contract writing Solidity, that is program version, the Solidity version, where you have to define it so that when we are compiling at the backend, that particular version will be looked at and code compilation will take place. And the next one is the declaration of the structures like a track product. And if you scroll down further, like a 29th line, and mapping, how this tracking can be mapped with the having an unique ID, like mapping of uint of track array. That means I'm trying to store all the track events that are happened during the time of contract transfer or contract creation in a particular array, and I'm going to map that with a particular track ID, whether it might be part ID or product ID. Here, if you see, there are two structures. One is a part structure where I'm going to track a product parts. Here in this in this particular contract, what it is being tried is you are having a product, and the product will have multiple parts. Let's take an example of a laptop. If you take this one, you have multiple parts like motherboard, keyboard, and mouse, and everything, or internal display parts, these type of configurations. Like I'm going to track complete product tracking and also complete each part tracking. Suppose if you take motherboard, this one will be manufactured by manufacturer A, and if you take display, this one will be manufactured by manufacturer B, but the assembly of the product will be taken place at some areas like maybe Lenovo or Dell or HP, these kind of assemblers. So when we are assembling a product, you need to know from where the origination of these product parts are being uh, sent to make sure that this is an good and genuine product. And where if the part is not derived or came from the registered manufacturer, then that will be considered as a default or faulty product, which includes the fault product. To track all this information, when a business design some rules and regulations like how we are going to map this product and parts, and when the business requirements are converted into a coding lines, that comes out this Solidity structure. And yeah, again coming back to our contract, like on that line number 29 and 31, we have each part tracking and product tracking mappings. And coming to line number 34, get length, we are trying to get the length of, that is nothing but trying to get number of events that are taken place. When I'm trying to create a product, an event will be created and that will be tracked. When I'm transferring the product, an event will be created that will be tracked. Now the length will be 2. These are all like, it's again based on your requirement and the business requirement, where you can write on your own, like if you need length or not, that is up to your choice. Like if you go further, yeah, here and the same, the product track length and the product track, and the line number 43 is saying how we are going to track the product track. Like now we are going to parse the fields which are stored in an array by sending it product id. Now if you see here at the line number 43, get product track of event pid and id, and which will give public view when we comes to the functions like public, private, external, this kind of visibility functions, and also view pure. If you go to solidity usages, then we can come to know what it is. And I'm going to return some particular fields. What I'm returning here is I'm going to return product id and the owner id, owner address, and the timestamp that this product is being created or transferred, and the current state of that product. And if you see at the function lab 48, it is the similar function for tracking out the parts. Now coming to the structures, like from the line number 53, if you see structure, how the part structure, what type of fields you need to capture while you are creating or registering a part. That is part id, part name, part number, state, and if there is some certificate or some image you need to upload, part id hash. Maybe that one you can upload in IPFS, or you can upload in some generic cloud storage S3 or Google Cloud and get unique ID from there and attach here. That is all again, it's a decision that we can make. And yeah, that one is the another one is 68 one, which is a modifier one, which you need to make sure that the update of the part can be only done by owner of that part. Once the part is registered by manufacturer A, updation to that part should not happen from manufacturer B. So these kind of restrictions can be maintained at contract level itself by usage of message.sender. Like when the during the creation time, you are storing message.sender as manufacturer A. During the time of updation, when you are trying to interact with that function, you will say that only owner should have that facility to update that part. That time you will give as a function access as only owner. And here this is assigning of the part, like that one you can consider this function as a creation of part. Here this particular approach or the implementation that is done in this contract is completely based on considering some of the requirements. Maybe it may differ from other applications or other supply chain contracts, or maybe that you can find in open source areas. But here what it is saying is registration of the parts. So I am going to have an unique ID that is created on every part registration, and I'm going to map that part ID in the structure that I have explained before and store all the values, necessary values. If you see at line number 77, part ID is being stored, and ownership, stakeholders of sid.user address. I'm storing here an unique Ethereum address to find out the owner of that part, and part unique number, parts number. And I'm going to create another structure we have to track that parts, that is 83 line if you initialize the structure, and I'm going to store this particular event in a different structure. And the other things are like function 93, line number 93, set part hash. You are going to update the hash. Maybe you are being asked to uh, update the hash later after the part creation. Then you have to use this function in this manner. Like you have to pass an unique ID that is being assigned for that part along with the update field that you require, where this is like generic structure updates or value updates in our database scenarios or backend applications. Here also we'll go with the same approach. If you have some familiarity on using how the JavaScript works, then it is better and more far convenient for you to understand this code structure as well. And this is again for having stakeholders structure. And now comes is the line number 116 is the product structure. What we are storing is product id, product name, product owner, product specs, and also we have an array declared here to store product parts also. Like we are going to store how many parts are involved in this product, and license, state, customer registration, remarks, or any secure SID, which is serial number ID or product ID hash. And 130 mapping, this particular type will be used to map to your unique values. And here function 138 is set stock stakeholders, is nothing but registration of your stakeholders. When I am explaining before, saying that manufacturer A, manufacturer B, C, D, assembler A, or maybe if warehouse is involved, or maybe if distributor is involved, or maybe if technical support is involved, everyone will be considered here as a stakeholder, and each stakeholder should be given an identity in our contract, in our business logic. That is the reason of creating or using this function number 138, line number 138, and we are going to store necessary information related to that stakeholder. Like coming below, yeah, we have now is the register product. We have parts created, we have stakeholders been set, and now is the product. Who is going to assemble this product? Like if you see at line number 166, we have received, for creation of this product, we have received, suppose the 3 parts are being received. We have to assign these 3 parts to this product, and also we need to track this information of updating these parts. Suppose you have received 3 parts saying that keyboard, motherboard, and display. First you received from the manufacturer A, assembler A is going to prepare this product. Now manufacturer A transferred this product to assembler A to integrate this product. Now assembler A might not use this product or might use, but after using it, definitely he needs to update status of that particular part as being integrated. That is the reason here in this function what we are doing is product assembly and also part tracking to maintain the authenticity of that particular parts and products. We are going to structure in this function. And the next one at the 187th one is the update product license. Like if you want to update some license after the product is prepared, by maybe product is also assembled, now next distributor is coming into picture, where he needs to create a license and distribute it to the warehouses or maybe end users directly. At that time he will update the product license terms during, by triggering to this particular product license function. And the state, maybe that product might be damaged or faulty, or maybe it is sent to direct customer. Current state of that product, we know usually warranty or these kind of features will be given for every product, right? Those kind of things will be tracked on updating the status of the product. And now coming to function 212, update product parts. I have received my laptop that is assembled by assembler A. I am not sure, after 2 years my keyboard got damaged and I had to replace this particular part. At that time, how I am going to update my product parts and also to have better tracking purposes. That one is happened at the update product parts function. And now for an admin purpose or for company related use cases, they need to see what is current state of the product, who is having this product, and what products are involved. For that we have get product function. Yeah, if you further come down, yeah, these are all like generic, based on the name itself you can figure it out why that is required, the function like set product hash, get product remarks, and get stakeholders, who is real owner of that product now, and how many stakeholders are present, or how many products are being created by with this contract, and how to make this stakeholder only can create product. We'll have the other function called login. We are going to give a login mechanism also directly in the contract, single contract itself. Yeah, if we further come down, yeah, we can see here transfer ownership of the product that I was talking before, where this function will take place in updating at the line number 289. if you see the address being updated, line number 293, the product ownership is updated with the second stakeholder. And even the same thing happens for the transfer of ownership of product. And this is all like a complete bifurcation of the Solidity contract when you are dealing with the business requirements and the way of conversion of your business requirements to the coding areas, and how it will be displayed at the execution level. Maybe we can see in this demo.
Thank you, Nag. So I think coming back, right? So this is the code builder where you don't have to really worry about the code. So we have a predefined contracts also coming out for each of the use cases across. Say that I remove this and I'm going to compile this. I will get the compilation error, and I can go and correct this, then put it back, then go and recompile it. So your code compilation is successful. Now I want to deploy it. Now your deployment can directly happen on the platform itself, writing a code, doing it, compiling it, checking for the vulnerabilities, then again going and deploying it. I'm going to deploy this now. So it takes a minute's time to, so your contract is deployed fully. So this is through the code builder format. On complete methods has been auto integrated, completely auto populated, fully automated, with the complete code which you can see visible, which is auto populated, and your bytecode. So now I have a standalone application. This is a standalone application. There is no UI UX as such for this, just for the demonstration purpose. Now I just want to connect the one which I created, the blockchain, and say that you have a standard Salesforce or SAP application. So I just want to go and connect that to it, right? I'll just say that I will put the API code, and then I will go and copy my bytecode, right? I'll copy my contract address. Then I will go and connect with my RPC URL. Okay, RPC URL, you just go and find out from here on how to connect and all. I will just copy this and go and connect. So your setup is done now. Okay, now your blockchain is connected to this network. So this is the application with different roles which we have. So I'll just demonstrate on how this works out, right? So we'll create some users. Say you will have a these are different. Consider this to be your pharma supply chain use case which you are building. Your manufacturer, say that I don't consider this assembler is something is not needed, but it's again one other function. So let's go and do that. Say manufacturer. I'll just go and put this one. And I'm going to put, so I'm going to register this. So this is registered on the blockchain network now. If you see here, the hash has been generated. So your user is registered on the blockchain. So I'm going to open a notepad. Mostly it's manufacturer ID is MNR1, right? I'm going to create one more user, assembler, right? It's generated. ASM2. So one more distributor. So it's successfully registered. So I have warehouse. So these are the several actors which we have. WHR4. Okay, now I'm going to go back and log into the system. Say MNR1. So I'm going to manufacture. So this is the application where I can track all my parts, right? I want to register my part now. Okay, so this is the part one. I will say something called sample one of your medicine. So I'm going to register this part. I'm going to register one more part. Your sample one details have come up. So you have a historical trail which is getting formed here, right? So who has created, when it got created, what is his unique address, what is the timestamp, which is fully tamper proof. So you will have a unique address for each of this user with a role and the user ID, right? So I'm going to transfer this. I will transfer this to the assembler. So this is the part one which I am going to transfer. So this particular part has been transferred. Now I'm going to log off and I will log in with my assembler ID. All right. In the meantime, you guys can put your questions. So I think we would be closing off in the next 5 minutes. So before we take up some Q&As, right? So I'll say sample two. So this is a product which we are building. So I'm going to register this. This got registered. So I assemble that particular part. I'm going to transfer this. I will be transferring this to the warehouse. This is the product one. This is sample two. I transfer this to the warehouse. Now I want to, you know, log out and log into the warehouse. Okay, so now I'll transfer to the distributor. So we transfer to 4 different people and we'll say DBT3. So you can create a retailer from here. So I want to track my product. So if you see here how this is getting formed, right? So from assembler it went, and so all your partners who are part of the network will be having a single source of truth across. If you see here, we have committed so many transactions now. Let's go and see. So all these are some of the transactions which are happening as we talk, right? So one moment. Let me just go and close. So these are the transactions which happened on that application, which is getting reflected across all the parties, all the partners who are part of the consortium, right? So in that way, you can really build any use cases on top of the platform by using Hyperledger Fabric, Quorum, or Ethereum, or whatever network you want. You can go and deploy any of the use cases across supply chain, logistic, retail, to government, to pharma use cases for medical traceability, device traceability, and all, right? So you can also, once you are done, you can also go and delete your work, delete your node directly. I go and put node one, and I'm done with this. So this is gone, right? I'm also going to remove this. All right. So all the notification comes up here. So this basically is done, right? So Satyakshi, if you can let me know the questions so we can answer to those. So let me just see what questions I have.
Hi, sir. Good evening. I guess there are no questions. So if you want to kindly introduce something about, I guess we have one question now.
Okay.
So can you see that?
Yeah, I did not. Which database? Which database in the sense? The question is not clear.
Parimal, can you just elaborate your question? Sir, there is a next question from Kannan. Can you just see?
Oh, one moment. I don't see how to check the blocks are valid. So Kanan, you have to go to the blockchain explorer is there where you can put your hash to see if the transactions are valid. So blocks, you don't have control on the blocks. Blocks keeps creating. So based on the consensus, you will have blocks keeps creating. So it's not about how to check the blocks are valid or not, but because blockchain is tamper proof, nobody can add some extra blocks into it. But however, you can check all the transactions.
Sir, I can see there are no more questions. So thank you for your valuable input. And thank you guys for joining this webinar. We will share the recordings with you by Monday and materials as well. So thank you for joining the webinar. Thank you so much.
Thank you all. Have a great day.
Thanks, Rajan.
Thank you.
Thank you all.